here is the next problem on our homework. So we got two freight cars, each with a mass of 300,000 kilograms, and they collide in an inelastic collision. So it's already told us the type of collision. One was moving at 2.2 meters per second, and the other was at rest. We want to know their final speed. So with this type of collision, this is our before. We've got one freight car moving at 2.2 meters per second, and then the other one is standing still. And then after they collide with each other, they're combined and they're both moving at a final velocity we don't know. So we got to figure that out. And one of them was at rest, so that makes our math a little simpler. We start with our equation, M1 V1 I for initial plus M2 V2 I equals our combined masses M1 plus M2, and those are multiplied by a final velocity. Givens, M1 is 300,000, M2 is also 300,000. V1I is 2.2, V2I is 0. So we can go ahead and put some numbers in. We've got M1, 300,000 times V1, 2.2. We don't have to worry about the second term because that car was at rest. So this equals 600,000. That's just my two masses combined, 300,000 plus 300,000. Times final velocity. I multiply those two out. I get 660,000 equals 600,000. And then I'll do my final division there. And I get 1.1. So my two cars are moving together at a velocity of 1.1, which is less than my original car that was moving, but it hit a car that was at rest. So, and we know for inelastic, kinetic energy is not conserved. Okay, so there's some energy that went into this combination of these two that occurred when they ran into each other. So we'll look at that real quick. Our initial kinetic energy is just the energy of the car that was moving because the other one's velocity was 0, so its kinetic energy was 0. So we've got 1/2 times m, 300,000, times 2.2 squared. That's our initial velocity. That gives us an energy of 726,000 joules. And then our final kinetic energy is going to be our two combined. So 1/2 times our combined mass of 600,000 times our velocity of 1.1 squared. That's our 1.1 we got here. And that's 363,000 joules. So that's half of our energy was transformed from kinetic into something else. And I'm sure there's thermal. Imagine these two huge train cars crashing together. So there's got to be some thermal. There's got to be some sound. There's probably some heat type like sparks that flew. I don't know. There's a number of different things probably that happened with this scenario, but definitely see here that our kinetic energy is not conserved. So, okay, let's see. All right, this one I think is an elastic. So let's see if we can do it because it should be faster. So we've got a 0.035 kilogram object moving at 475 meters per second. And it strikes a bag of flour that's on ice at rest. It passes through the bag and exits it at 275 meters per second. So we want to know how fast is the bag moving when the object exits. Okay. So initially we've got some kind of object that's traveling, and this is an elastic collision. It's traveling towards a bag of flour that's on ice for whatever reason. And then after it's going to have passed through the bag, so I'll make kind of a dotted line to show that, it's still moving, and the bag is also now moving due to the impact of this object colliding with the bag. Okay. But they didn't stick together. Like this object passed straight through the flower. So there's no, so this is an elastic collision. Okay. So let's look at our equation. M1V1I plus M2V2I equals M1V1F plus M2V2F. Givens, M1 is 0.035 kilograms. V1I is 475. M2 is 2.5. V2I is 0 because it's at rest initially, the bag of flour. Let's see. And then V1F equals 275. And V2F is what we want. And it's important with these that you write down all your givens and you keep everything straight because it can get confusing. And you can see that from this example. It can get confusing otherwise that, you've got multiple masses and then you've got multiple velocities. So, all right, so let's put some numbers in this. M1 times V1I plus 0 because this was at rest, so that's kind of nice. That makes it a little simpler. Equals 0.035 again times 275 plus 2.5 times V2F, and that's what we want to solve for. So let's do a bit of simplifying. 0.035 times 475 is 16.625 equals 0.035 times 275, 9.625 plus 2.5 V2F. I've got to subtract this from both sides. That gives me 7. That's nice. 7 equals 2.5 V2F. And then I divide both sides by 2.5. And that gives me 2.8 meters per second is my V2F. So this collision of this object going through the bag of flour set this bag of flour moving 2.8 meters per second from rest. So that's pretty fast considering it was at rest. Now this object is going way faster. Is kinetic energy conserved? Yes, for elastic collisions. So we're not going to worry about calculating any energy values here. We're just going to go with kinetic energy being conserved. So, okay, so that's number 2 and number 3.